Hello students, today we are going to continue with chapter 13 of science, motion and time. Our first topic for today is measuring speed. Before we start with our today's topic, let us have a quick look on the formulas. How can we calculate speed, distance and time of a moving object? For calculating speed, if total distance and total time is given to us, we can calculate the speed, and the formula for speed is total distance covered over total time taken. For calculating the distance, we use formula speed multiplied by time, which will give us distance covered. For calculating time, the formula is total distance covered upon speed. All these three formulas are taken out from the formula of speed itself. Our next topic is odometer and speedometer. Odometer is a measuring device which measures the distance covered by the vehicle. And on the other hand, speedometer is a measuring device used to record speed of an vehicle. Here in this picture, you can see this is odometer, which is telling the distance covered by the vehicle. Now, this is speedometer. From this speedometer, we can observe the vehicle is moving at what speed. It measures speed in kilometer per hour unit. You can find speedometer and odometer in all the vehicles. Now, last topic of this chapter we are going to discuss is distance time graph. Here we are having a table with some particulars or data like time, odometer reading and distance from the starting point in kilometers. Now, suppose you are going with your parents for picnic. You started at 7 a.m. and your odometer reading by that time is 56780. At 7:30 a.m., odometer reading was 56800. Similarly, 8 a.m. and 8:30 a.m. the reading was this. Now, distance from starting point, distance covered at 7 a.m. was 0 kilometer. At 7:30 a.m., vehicle travelled 20 kilometer. We subtracted these two readings. Now at 8 o'clock, 40 kilometers. At 8:30, the distance covered was 60 kilometer. So based on this, we can plot a distance time graph. The distance time graph is a line graph. This graph shows that the vehicle is moving with a constant speed. So we'll get straight line. This is the distance time graph. This one is x-axis and this one is y-axis. Time is represented on x-axis and distance in kilometer is represented on y-axis. So here at 7 a.m. the distance covered is 0 kilometer. At 7:30 a.m. the distance travelled by vehicle was 20 kilometer. So we can mark here. At 8, distance travelled was 40 kilometers. So I'll mark it here. And at 8:30, 60 kilometer. In this way, we got a straight line which represents the vehicle is moving in a constant speed and in uniform motion. If a vehicle is moving in uniform motion, we will get a slanting straight line graph. And if the vehicle is at rest, we'll get a graph with straight line this way. And if vehicle is moving in non-uniform motion, it means the speed keeps on changing, then the line we get on graph will be a curved line like this. Using the same data, you can make a bar graph and a pie chart also. Now, some of the points to keep in mind while choosing the most suitable scale for drawing a graph are the difference between the highest and the lowest value of each quantity. the intermediate values of each quantity so that with the scale chosen it is convenient to mark the values on the graph and to utilize the maximum part of the paper on which the graph is to be drawn. So here we complete our chapter 13, Motion and Time. See you in my next lecture. Till then, bye bye kids.